All right, welcome back to section 13.3, volume of solid shapes, and we're still looking at prisms and cylinders. So here's another volume problem. The front and back of a storage shed are shaped like isosceles right triangles with two side lengths of 10 feet, as shown on the left, so over here. And the storage shed is 40 feet long, so you can kind of see the side view. Determine the volume of the storage shed. So Xing solves the volume problem as follows. First, he uses the Pythagorean theorem to determine that the length of the unknown side of the triangle shown is the square root of 200 feet. Then Xing uses the Pythagorean theorem again to calculate the height of the triangle H if the base is the side of the length. So now he's looking for the height of this triangle. So he got this side length, then he's looking for the height of the triangle, and he finds that height by doing this calculation here, and then determines the floor area of the shed, and then calculates the volume. All right, so is Xing's method calculation correct? All right, so let's go through it piece by piece. So first, let's see if he uses the Pythagorean to determine this side length correctly first. So he's got 10 by 10, that's it, and then this. So it would be 10 squared plus 10 squared equals side squared. So that would be the square root of 10 squared plus 10 squared. 10 squared plus 10 squared is 100, so that part is correct. So far so good. Then to calculate the height, he carries out the following. So let's see what he did here. So if we know this triangle is the square root of 200, 10, 10, he wanted this height. So it looks like he probably grabbed, one of these little guys. So let's see how he did there. So that'd be 10h. Well, what would this length be? Well, that would be half, right? Because it's half. So far so good. Let's see how his calculations went. So here's the right angle. So that would be h squared plus square root of 200 over 2 squared equals 10 squared. So that matches. And then we would subtract that on both sides. Now, if we square that, that would be 200 over 4, so that's correct. And then 200 over 4 is 50, that's correct. 100 minus 50 is 50. And then he square rooted both sides, so that's also correct. So then he determined the floor area of the storage shed as 40, this one is 40, times that is square root of 200. So he decided that that is the area of the base, and that is incorrect. When we find the volume, the base here is actually the triangle. So that is where Xing is incorrect. So now we need to solve it in a different way. So instead of using the Pythagorean theorem, because that's what he did, let's think about these two triangles. Remember, those two triangles as part of a square. So we know that this is a 10 by 10 square. So we want the area. Remember, volume is the height times the area of the base. So we know that this area is 100, so half of it is 50. And the height in this case would be 40. So the volume here is 2,000, what do we got, square feet. I mean, not to say Pythagorean theorem isn't cool, but my goodness, we were able to figure that out quicker. I probably wouldn't have done that either. I probably would have done Pythagorean theorem, but they said do it in a different way. So go ahead and give these a try. I know there's a lot. Take your time. These problems are challenging. It is important to give them a try, and then press play when you're ready to see the solution. All right, let's move on to pyramids and cones. So recall that pyramids and cones are formed by a base with an apex. And the height of the pyramid or cone is perpendicular distance between the apex of the pyramid or cone and the plane containing the base. So just don't think that the slant is the height. The height is the distance, right, from the base to the apex. All right, so now is an exploration. We've got those downloads. You're going to need like beans or some sort of something to fill. I really, really strongly recommend you not skip this one. You're going to learn a lot about volume here, and it's going to make a lot of sense. And then do this exploration and press play when you're ready to move on. So hopefully you saw in those explorations that the formula for volume is 1/3 times the height times the area of the base. So in this way, the volume is 1/3 of the prisms and the prisms and the cylinders. And hopefully you were able to see in those explorations, that's what we call those, why that 1/3 makes sense. So let's do an example here. So a construction company wants to know how much sand is in a cone-shaped pile. So a cone has a circular base and an apex. The company measures that the slanted distance from the edge of the pile at the ground level to the very top of the pile is 55 feet. And the company also measures that the distance around the pile at the ground level, so the whole distance around here is 220 feet. What is that distance around? That's the circumference. How much sand is in the pile? So that's what they're asking, is the volume. So what do I know about the volume? I know that the volume for these are 1/3 times the height times the area of the base. So what do I know here? Well, I can find the area if I have the radius. Well, I have the circumference. Circumference is pi times the diameter. So if I divide both sides by pi, so 220 divided by pi, I will get about 70. And so my radius will be about 35. So I can find the area is pi r squared. So I'm getting closer. So the area here is about, let's say 1,225 pi. So I've got this piece, right? This is, we're getting closer. I just need the height. So how can I figure out the height here? Let me pick a different color. The height, remember, is this distance here. It's not the slant height. But I can already see here, if I can make a right triangle, I can use the Pythagorean theorem. So this is the height of the triangle, and look at that, that's the radius, that's 35, and that's 55, so I can use the Pythagorean theorem. So that tells me h squared plus 35 squared equals 55 squared. So h squared equals 55 squared minus 35 squared, so it's the square root of 55 squared minus 35 squared, so that's about 42.4 feet. So my height, I'm going to come back over here, is 42.4, so if I multiply all those together, I get a volume of about 54,391 cubic feet. That's a lot of sand. Go ahead and give these problems a try. Press play when you're ready to see the solution. And there you go. And again, we saw these in the explorations. So now let's talk about the volume for a sphere. It's a little different. It's 4/3 pi r cubed. So it doesn't surprise you that there's a cube because we're talking about a three-dimensional shape, and pi because we're talking about circles, but where does that 4/3 come from? So one way to derive the volume formulas with calculus, but another way is to show how the volume of half sphere is the same as the volume of a cylinder with a cone removed. And it gets kind of interesting here, but we're going to actually use the next exploration to examine the details. So go ahead, you can pause here and read this a little bit more, and then do this exploration. Press pause here and press play when you're ready to move on. So a common source of confusion is the difference between volume and surface area. So in the next exploration, we're going to look at the difference between the two. So go ahead, this one is a great one. You're going to need some graph paper if possible, and just kind of see how these are related, how they're different, and that's going to help you with students kind of making sense of the difference and the distinction between the two. And just a little bit from the field here. Using origami, just making sure that we can see how these things are created and made. And that's going to go ahead and conclude section 13.3.